Hello and welcome to 5-Minute Math. Today we are looking at the 8th grade concept of slope and y-intercept. This is standard 8.2c in the great state of Texas, and we are using item number 39 off the 2016 released STAAR test. If you have not done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we have a graph of a linear function. We can tell it is non-proportional because it does not go through the origin right there. And we simply need the y-intercept. And as you can tell, we don't have any A, B, C, or D to choose from, so we're going to have to figure that out on our own and then bubble it into our griddable response if we were taking this on a paper version of the STAAR test. So what does that mean, the y-intercept? Well, we are used to looking at our linear functions like this. Y equals mx plus b. And so our y and our x coordinate are just going to be represented by y and x. So we've got two things in addition that we're always looking for in this slope-intercept form. So the slope is going to be this m, and we just represent it with the letter m. And so that is going to be our rise over run. So that's the change in y over the change in x. So if we wanted to actually calculate that, we would take two y coordinates, subtract them. That's my numerator. Two x coordinates, subtract them. That's our denominator. We can actually do that because look, they give us 2 points here, right? So I can take my two y coordinates, doesn't matter which one you put in first, so I'll do -9, -6. And then our two x coordinates, just make sure you match them up. You've got 1 minus -4, right? So your -9 minus 6, that's going to be -15. Your 1 minus -4, those two cancel each other out. Two negatives make a positive, so it's really 1 plus 4. So it's going to be -15 over 5. So 15 over 5 is 3. You got a negative, so really it's going to be a slope of -3. So if I wanted to, right, I can rewrite this y equals -3x. So we've calculated our slope, but then we need this b right here, and that's the y-intercept, and that's what we're looking for right here, is our y-intercept. So what this supposes is what happens if we make our x 0, right? If our x is 0, so I'm going to take this, and I'm going to bring it over here. Y equals, we already say our slope is 3, so let's say we make our x of 0. Well, what happens if our x is 0? Well, then the y just is going to equal whatever's left over. And if it were a proportional line right here, then we would say that y would equals 0, right? If x is 0. But it's not. It doesn't go through the origin. So that's why we've got this plus b. This is going to actually represent our y-intercept. So what we're looking for is, where does this line actually cross our y-axis? And it's kind of close, but it looks like it's crossing right there. Looks like we're going to use an integer right there. So it looks like it's going to be -6. You see, it's not quite the -5. It's not quite the -7. So really, instead of, if our x is 0, instead of leaving our y at 0, we're going to see that when x is 0, it intercepts this y-axis right there at -6. So that means our y-intercept is going to be -6. So if our x is 0, then y becomes -6. So this is our completed slope-intercept form. That's going to be y equals -3x minus 6, and our x becomes 0, right? Then we just have a y-intercept of -6. Now obviously we've got to fill this in, but it's not going to be super difficult here. Right, we've got just decimal. We've got 2 spots to the left, or to the right of the decimal. We've got 4 spots to the left, and then we've got a plus and a minus here. So in this case, we are going to need to bubble in that negative right there. And put a 6 right there, and bubble it in down there,